Next up, we have Sarah Stutsman from Corona Norco Unified School District, and she is going to talk about her project, Auto-dissemination, a novel and effective tool in mosquito control. I got the question mark right there, Sarah. There you go. Sarah, take over.
Hi, I'm Sarah Stutsman. I'm a current junior at Corona High School. I've been doing science fair projects since I was in the 3rd grade, starting with dissolving Peeps candy and laundry detergent. Through the years, I've learned a lot from older student researchers who have shown me a lot of advice, and I hope to relay some of that to you. So last year for my project, I determined whether the N2 hair trap, a specific trap designed for mosquito control, is an effective tool. Mosquitoes are responsible for over 700,000 deaths each year due to the many diseases that they transmit. This is why mosquito control is so essential. Aedes mosquitoes, a specific type of mosquito, tend to skip oviposit, a survival method in which they lay eggs in many different sites to increase their survival rate. The N2 hair trap takes advantage of this through the use of auto-dissemination, a method through which mosquitoes pick up pyroproxyfen, which is a larvicide that prevents mosquito larvae from becoming adults, and spreads it to other breeding sites, helping to reduce mosquito populations there. A fungus, Bavaria bassiana, then kills that adult mosquito. So to test the trap's efficacy, I placed sentinel cups at varying distances from the N2 hair trap for either 2 or 8 weeks. I then poured the contents from the cups into clear observation cups, along with Aedes aegypti larvae, and recorded any signs of larval or pupal mortality in the larvae. Unfortunately, most cups had high adult mosquito emergence rates of over 70%. The expected emergence rate from a previous semi-field study was 20%. Therefore, I can conclude that while the trap may work in theory, in this specific scenario, the N2 hair trap was ineffective in a field setting. It did not spread enough pyroproxyfen to other breeding sites to cause larval mortality. So these results did not turn out the way I originally thought they would. However, this does not mean that a project is considered a failure. Most of my past projects have taken this route. Having unforeseen results is why we do science in the first place. It leads to questions such as, why did this trap not work in a field study when it had originally worked in a semi-field study? Judges like to see your thought process and how you respond to a project that may not have given you impressive results. And these questions can lead to future continuation projects. For example, this year, I'm starting to look at the same trap, but I'm going to test how mosquitoes behave with it using a different methodology. Something else I would like to highlight is how beneficial mentorship is. Even if you're not working with that person, it is always helpful to talk to a professional in your field about your project. Not only can they challenge your thinking, but they can also provide feedback and suggestions. Currently, I'm working alongside my local vector control department, and this is how I'm able to obtain materials that I need for my project and guidance. I went to them a few years ago to ask about an area in mosquito control that would help them out personally, and this led to the ideas for my past 3 projects. Another point is that you will run into problems during your experiment. Since I tend to do field experiments, I run into multiple problems such as cats drinking out of cups that I need for data, the cups being knocked over. So to prevent this, I ended up having to build these rock barriers around the cups to keep them standing up. Another problem I ran into was the cold weather. So because it started getting colder, mosquito larvae and pupa started to take longer to develop. So I had to start using a heater and eventually bring the cups with mosquitoes inside so that they could develop into adults or die off. So my recommendation is to include these issues that you face in your report. Science comes with mistakes, and it's important to see your thinking process and how you respond to those mistakes. It's also really important to include the world impact in your project. Why should we care about your experiment? So for example, for my project, mosquitoes transmit many diseases such as malaria, Zika, and West Nile virus. And it's important to keep these mosquitoes under control to control the diseases too. And science fair leads to many different opportunities with the competitions. For example, I was lucky enough to be able to visit ICEF in person as an observer and then later virtually as a finalist. With these competitions, you meet new people and make new friends, and it's pretty great. So thank you for joining me. I hope you enjoyed my presentation, and good luck on your projects.